Welcome. This deck walks through the SAML single sign-on flow twice, once as a real user experiences it in a browser, and once as a JMeter load testing script has to build it by hand. The real goal here isn't just understanding SAML, it's identifying exactly what information a JMeter scripter needs up front to build a script that can simulate hundreds of concurrent logins without breaking. Here's the roadmap. We'll start with the SAML flow at a high level, then walk through it step by step, comparing what the browser does automatically against what JMeter has to do explicitly. After that, we'll summarize why this asymmetry exists, and spend the second half of the deck on the real focus, the specific information checklist a scripter needs from the SSO and application teams before they can build a working, concurrent user-ready script. At a high level, three parties are involved: the browser, representing the user, the service provider, which is the application being protected, and the identity provider, which handles the actual login. The browser talks to the service provider first and last, steps 1 and 7, and in between it's ping-ponging with the identity provider through steps 2 through 6. Keep this shape in mind, because every side-by-side slide that follows maps onto one of these 7 steps. Step 1 is simple on the surface. A user types in the URL or clicks a link to a protected page, and the browser sends a plain GET request. No session cookie yet, because this is a fresh visit. The service provider looks at that request and realizes the user isn't authenticated. For JMeter, this step is just as simple to build, but there's one thing that trips people up. You have to confirm the exact URL of the protected resource with the application team, not the SP's generic homepage. And make sure the cookie manager starts empty for every thread, exactly like a brand new browser. Now the service provider redirects the browser to the identity provider. This happens via an HTTP 302, and it carries 2 important values as query parameters: SAML request and relay state. A real user never sees this, the browser just follows it. In JMeter, you have to catch that redirect deliberately. Either disable auto redirect on this one sampler so you can read the location header yourself, or add an extractor right after it. And here's the critical question for your SSO team. Is relay state a fixed value tied to the application, or does it change on every single request? If it's dynamic, it must be correlated. You cannot hard-code it. Once redirected, the identity provider shows a login page. Visually, it's just a username and password field, but under the hood there are almost always hidden fields: a CSRF token, a view state, sometimes an execution ID, depending on the IDP product. The browser stores and resubmits these without the user ever knowing they exist. JMeter has to extract every one of them from the login page's HTML using a regex, CSS, or XPath extractor and play them back on the next request. Otherwise, the identity provider will reject the submission as forged or expired. This is exactly why knowing which IDP product is in use matters so much. Each one names these hidden fields differently. The user types their username and password and clicks Sign In. The browser posts those credentials, plus all the hidden fields we just talked about, to the identity provider's login endpoint. For the script, this means replicating that post exactly. Same field names, same encoding, while pulling username and password per virtual user from a CSV dataset config. This is also where test data planning becomes critical. If the script reuses one recorded account across many concurrent threads, the identity provider will very likely lock that account out, and that failure will look like a performance problem when it's really a test data problem. This is the step that catches almost every JMeter script off guard. After validating the credentials, the identity provider builds a signed SAML assertion and returns an HTML page containing a hidden form with the SAML response and relay state values, targeted at the service provider's assertion consumer service URL. In a browser, a small piece of JavaScript fires on page load and submits that form automatically. The user just sees a brief flicker. JMeter doesn't execute JavaScript at all, so this auto-submission has to be built manually. Extract the SAML response and relay state from the HTML, then construct the post to the ACS URL yourself. If you take away one thing from this whole deck, it's this step. Get the exact ACS URL and its parameter names confirmed with the SP team, because some identity providers rotate them. Pause. The browser posts that assertion to the service provider's ACS URL. The SP verifies the signature, checks the assertion is from the right audience and still within its validity window, then sets its own session cookie and redirects the user to the page they originally asked for. JMeter mirrors this with a post of the still base64 encoded SAML response and relay state, and the cookie manager automatically picks up that new SP session cookie. One thing that's easy to overlook: confirm the assertion's validity window with the SSO team, and make sure the load-generating machine's clock is synced via NTP with the identity provider. Clock drift here causes intermittent failures that are very hard to diagnose. From this point on, it's simple. Every subsequent request just carries the session cookie, and no more SAML activity happens until that session or the underlying assertion expires. JMeter behaves the same way. Later samplers just rely on the cookie manager. The only reason to replay the whole SAML sequence again mid-test is if you're intentionally simulating a session expiring and the user re-authenticating. So it's worth confirming both the SP's session timeout and the identity provider's SSO session lifetime up front, since that tells you whether a long-duration test needs a scripted re-login built in. Stepping back, here's the pattern across all 7 steps. Everything that a browser does, invisibly and automatically, running JavaScript, following redirects, managing cookies across 2 different domains, remembering hidden tokens, a JMeter script has to do explicitly, by hand, correctly, for every single one of potentially hundreds of concurrent simulated users. That's really the whole challenge of SAML load testing in one sentence. So that's the flow, and that's why it's hard to script. Now, let's turn to the part of this deck that matters most in practice. What specific information does the person building this script actually need, and who do they need to get it from before they write a single sampler? First, endpoints and bindings. The scripter needs the exact SP protected resource URL that the test should start from, not the SP's marketing homepage. They need the identity provider's SSO URL and the service provider's assertion consumer service URL. They need to know which SAML binding is used for the orphan request, redirect or post, since the response is almost always post. And they need to know about any WAF, CDN, gateway or proxy sitting inside that redirect chain, plus which environment, dev, stage or production, the test is actually targeting. Second, form fields and hidden parameters. Knowing which identity provider product is in use is almost the single most valuable piece of information here, because it determines every hidden field name. Beyond that, the scripter needs the exact username and password field names on the login form, the names of every hidden field, like CSRF tokens or view state, and which requests need to carry them. And they need to know the expected content type and encoding for that login post, so it matches the browser's request exactly. Third, session cookies and timing. There are 2 separate cookies to track, one for the SP session and one for the identity provider's own session. And they live on different domains, so both the cookie names and their domain and path scoping matter. The scripter also needs both session timeouts, the SP's and the IDP's SSO lifetime. And critically, they need the assertion's validity window, along with confirmation that the load-generating machine's clock is synchronized with the identity provider. This one causes some of the most confusing intermittent failures if it's overlooked. Fourth, Test accounts and concurrency behavior at the identity provider. The unique account pool needs to be at least as large as the target concurrent user count. It's essential to know whether the identity provider invalidates a user's previous session the moment they log in again elsewhere, because if it does, you cannot reuse the same account across multiple concurrent threads. The scripter also needs the account lockout and rate limiting thresholds, and any specific claims or group memberships the test accounts need in order for the application to actually function once they're logged in. Fifth, and this is important, the blockers that have to be cleared before scripting even begins, because none of them can be solved inside the script itself. Multi-factor authentication, push, OTP, SMS, has to be disabled for the test account pool because JMeter cannot approve a push notification. Capture and other bot challenges have to be excluded for load test traffic. Device fingerprinting logic that behaves differently on a first versus a repeat login needs to be understood. The load generator's IP addresses may need to be allow listed at the WAF or identity provider. And if the identity provider is a third-party service like Okta, Azure AD, or Ping Identity, get written sign-off and a scheduled test window, because unscheduled load will very likely get rate-limited or flagged as an attack. This slide is meant to be practical. It's a condensed, one-page version of everything we just covered, and the idea is that it can be handed directly to the SSO and application teams before scripting starts. Every single line on this page corresponds to something that has actually broken a SAML load test somewhere. Getting ahead of these questions turns SAML scripting from a frustrating trial and error process into a predictable one. The core idea to leave with is this. The browser hides an enormous amount of complexity from the user, and when you're building a load test, the script has to own every bit of that complexity instead. But if you go in with the endpoints, the field names, the cookie scoping, and the test account behavior already in hand, the script mostly builds itself from the flow you already understand. Thank you.